Good afternoon, everyone. In these 5 minutes, I'm going to explain you which choices we made to build an architecture to deploy thousands of PG clusters almost every month. My name is Léo Unbekandt. I'm CTO and co-founder of Scalingo. Scalingo is a platform as a service hosting company and database as a service hosting company, doing especially PGSQL cluster hosting. So first, fasten your seatbelt. I'm going to show you with a couple of diagrams the different technical choices we have done to deploy our PG clusters. So first, we have done the choice to use Patroni to handle replication and automatic failover between the different instances of our PG for each cluster. Patroni is backed by etcd in our case, which is handling the quorum to ensure that there is only one state and one source of truth. On the backup side, we have been using pgBackRest to take the wire segments and upload them to a S3 compatible storage, as well as the base backup from PGSQL. For the networking part, to handle also some high availability to access the database, we have some HAProxy gateways, which are here to be always configured to target the healthy leader instance of the cluster. And those HAProxy instances are backed by a virtual IP, which is always targeting the HAProxy, which is the one which is healthy. So at each point, the goal is to have redundancy on the networking part and then the storage part. Concerning storage by itself, we had this constraint that we wanted to propose several tiers of performance, several tiers of databases, including really small PG deployments and really large PG deployments. So for the very small one, we took the decision to mutualize storage, and we used LVM-based stack to create virtual blocks storage for the different instances. So each instance has its own logical volume, the LVs you're looking here, which is encrypted with a dedicated encryption key for each PG instance. So thanks to this kind of setup, we have something which is really flexible, because for each PostgreSQL database, we are able to scale the size of the LV dynamically, as well as the performances, the IOPS that we are giving to any database which is deployed. On the networking part, each cluster is in its own private network, where we are using some kind of overlay network based on VXLAN technology. So here on this diagram, you can see that there are vertically 5 different servers and horizontally 2 private networks. And so on the first private network, there is 1 cluster. And on the second one, there is a second cluster. And in each cluster, all the databases have exactly the same IP address map. And they don't see each other. They are not able to interact with each other. And they are completely isolated from each other. To do this, we developed a technology named SAND, which is Scalingo Awesome Network Daemon, actually. With all those pieces, are we satisfied with the kind of architecture we have now? Actually, last year we started 30,000 PGSQL databases, short or long-lived, with or without HA, high availability, multiple sizes of databases, multiple amount of nodes, and it has been working smoothly. On the storage part, the biggest databases have around 12 terabytes of storage per node, and so the system based on LVM worked quite well for that. And so far, it has been running in production for 5 years, and we improved it years over year to provide more features to our customers. So to sum up, with these technologies I've named, we had replication, high availability on one side, the backupping part, the networking part, the ability to be dynamic on the storage part, and above all, our customers, they just have a host and port couple to connect to the database, and everything about redundancy, failover is hidden behind the virtual IP that I've named first. So to do this, We used several tools which were developed maybe by some of you. So thank you to the wonderful PG community. And thank you for listening to me in this presentation.